Alright guys, we're finding vertical asymptotes and holes. So remember, vertical asymptotes and holes exist when the denominator is equal to 0. Because anytime we're dividing by 0, the function cannot exist at those points. So we find where would be the denominator be equal to 0, and we know the function won't be there. It'll either have a hole there, or it'll have a vertical asymptote because the function can't exist there. So we're looking for places where the denominator would be equal to 0. So the first thing we need to do is we need to factor the top and bottom. So when I factor the top, this is x minus 5 times x plus 3. And the bottom is x plus 3 times 2x plus 1. If you're struggling with factoring, let's get that practice down so that you can get really good at that and not have to get stuck on that for these ones. So now we look at this and we ask ourselves, what would make the denominator equal to 0? Well, if x plus 3 was equal to 0, x would have to equal negative 3 for x plus 3 to equal 0, right? So we know that if I put in negative 3 right here, I would get 0 out. That would make the entire denominator 0. So I know that I have some type of discontinuity, or some type of problem, I like to say, at x equals negative 3. Then what about 2x plus 1? 2x plus 1 equals 0. I subtract 1 from both sides and I get x equals negative 1/2. That means, again, I have a problem or a discontinuity at x equals negative 1/2. That means the function doesn't exist at this point. So those 2 points are my discontinuities. They're either going to be an asymptote or a hole. They're definitely one or the other. So, remember that's x plus 3. So when I look at this, I have to ask myself, how do I know if it's a hole? I notice that the top, x plus 3, and x plus 3 on the bottom can cancel out. So what I know is that that's a hole, okay? It cancels out and it simplifies to x minus 5 over 2x plus 1. Now this top function and the bottom function look exactly the same. The only difference is this is going to have a hole at negative 3 and this one isn't. So that's how we know it's a hole. It canceled completely out. So we know there's a hole at negative 3 something. We just have to figure out what that something is, because remember, a hole is a point. It's a point on the graph. To figure out what that something is, we plug in negative 3 for x, and we get negative 3 minus 5 over negative 6 plus 1, which is negative 8 over negative 5. So we know we have a hole at negative 3 8/5. So that's a point on our graph. And then we know that since this 2x plus 1 did not cancel out, we have a vertical asymptote at x equals negative 1/2, and we can just write it like that because it's a line. It's just written like the equation of a line. So that's finding holes and asymptotes.